Hello students, welcome to Target AES. Let us continue with our second module of hydraulic machinery and I am going to start impact of jets. In syllabus sheet, you might not find impact of jets as a separate topic. Even then you have to study this because this is sub part of turbines. Let us try to understand what is the importance of this impact of jets. We know turbines are energy producing hydraulic machines, right? So it is converting the fluid power into electric power. Let us say this is my dam. Okay, so here I have my reservoir. ये हो गया मेरा reservoir. So from reservoir I am having a huge pipe which is carrying water, right, to the turbines. So this pipe I am calling what? Penstock, right? So there will be surge tank also. यहाँ पे surge tank रहेगा, but let us ignore for the time being. We will study that in later stages. And then we will be having the nozzle of this penstock and water will be sprayed at a high velocity. Obviously, right, more the head, more velocity of water will be there. Common sense की बात है. And whatever this water is coming, it will go. And what it will do? It will impinge with the vanes of my turbine. Agreed? Just give me a second. Let me draw this properly. Yeah, something like this. Now it goes and impinges with my vane. So what happens? This vane will rotate. Agreed? So as the vanes are rotating, my entire turbine is rotating, right? My entire runner is rotating. To be precise, my runner is rotating. Shaft will be attached to my runner. So the shaft will also be rotated. Okay, what is happening? This water force, whatever came, it is responsible for the torque of my shaft. What is happening to the shaft? Shaft is rotating, the torque is being produced. What is the magnitude of torque? That is nothing but my force into the radial distance r. Agreed? So F into R is the torque being produced and this torque is responsible for the electricity which is being produced in my turbine. Okay, more the force, more will be the torque. That means with more torque, my shaft will be rotating. It is coupled with electric generator and more electricity will be produced. In simple language, more the force, more will be electricity produced. With more force, water coming and hitting, more electricity produced. That's why whenever we are trying to study these turbines, the first thing what we have to do is we should know what is the force of water which is actually going and hitting my turbine vanes. Agreed? So this chapter is of very high importance. Now comes a very important question. How to find this force? Using Newton law. कुछ है ही नहीं है इसमें. Using Newton law we can find it out. So we have one equation or principle which is called as impulse momentum principle. Give it 5 star. This can be asked as a 1 mark bit in state PSC exams. How to get the force which is being exerted on turbines. What is the principle? There will be 4 principles given. You have to take the right principle which will be impulse momentum principle. Okay? So this impulse momentum principle says the force acting on a fluid mass is equal to change in the momentum per second in that direction. In simple language, he is saying force is equals to change in momentum per second. Okay, what is momentum? Momentum, you know, right? P is equals to mv. P is momentum, m is mass, v is your velocity. You know what is momentum from your 8th class physics, 9th class physics only, you know that. So my momentum is mass into velocity. And I am saying here in this impulse momentum principle, the force is nothing but change in momentum. So d by dt, right, into momentum which is mv. So this is my impulse momentum principle. F is equals to d by dt of mv. Okay, simple si baat hai. I hope you got it. Now see what I am doing. You know, mass of a particular body will be constant, right? Mass is constant, so I can take the mass out. Mass of fluid is not changing, right? It will be constant whatever condition you take. So mass I am taking out, d by dt into velocity. Okay, so I can write my force which is acting on this vane is mass of fluid into dv by dt. What is dv by dt? It is nothing but change in velocity. क्या होता है? Acceleration. You know from your high school physics, what is dv by dt? It is nothing but acceleration, right? याद आ गया? So it is nothing but your Newton's law, what you have studied, F is equals to ma or mg. That is nothing but this equation here. If you simplify, you will get your Newton law only. Okay, force acting on a fluid mass is equals to change in the momentum per second in that direction. But it can be asked for 1 mark bit, so please be careful. Okay, he can change the terminology and ask. That's why I am saying direct नहीं पूछेगा, थोड़ा twist karega. Okay, force is related to, he can give you 4 terms like that, and you have to take the right answer. Okay, so it is related to change in momentum. So there will be like dmv by dt. There can be another equations, there can be like d by dt into m by v. So like that he can give you 4 options, you have to take the right answer, which is d by dt mv. Okay, okay. So if you simplify, you will be getting our Newton law, which is nothing but F is equals to ma. काफी simple है, काफी easy है, you can correlate, right? So I can write the force which is actually acting is equals to mass into acceleration, and acceleration I can write in terms of velocity as v minus u by t. Why I can write like that? अरे यार, v is equals to u plus at. Again the same formula which we have used in our 8th class or 7th class, u plus at. So what is your acceleration? V minus u by t, right? Simple. So I can write like that. So what I am doing is m v by u, v minus u, this is velocity components, right? So keep it aside. I am writing m by t as one term. Okay, okay, m by t as one term, and I am writing this m by t as m naught. I am introducing a new term m naught, which is nothing but mass of fluid which is striking my vein per unit time. Okay, m is mass of fluid, m by t I am considering it as mass per unit time, as simple as that. Okay, so let me make it very clear, whatever this m naught is there, that is m by t, right? So what is mass in terms of density? Density is mass by volume. So I can write my mass as density into volume. So let me erase this, बहुत सारा लिख दिया है, लेट मी एरेज दिस सो दैट यू वोंट बी कंफ्यूज्ड. समझ नहीं आ रहा है ना? कॉन्सेप्ट इज वेरी सिंपल, नो नीड टू वरी एट ऑल. सो आई कैन राइट दिस एम नॉट एज रो into volume, because mass is rho into volume divided by my time. Okay, simple. So what is volume by time? Volume per unit time will be your discharge, right? Volume per time, volume is meter cube, right? And time is second, meter cube per second. What is the unit of? It is nothing but unit of discharge, right? Volume per unit time, what is it? It is discharge. So density into my discharge is nothing but my mass which is actually hitting my vein per unit time. Concept clear है? याद रखोगे? So here I can write it as rho q directly, this m naught as rho q directly, or q is equals to u av. You know this formula, q is equals to av. So you can write it as rho a, let me erase this, rho a v. Okay, instead of rho q I can write it as rho a v. Done. Clarity आ गया. So what is my equation? Let me rearrange. My force was m naught into v minus u, right? Just above I have derived it. So I can write it as rho av into v minus u. This will be my force equation which I will be using from here on. I hope it is clear. So I will be extensively using this formula all over this chapter. Only one formula will be using rho av v minus u, but this can be modified into different ways. Okay, so totally there are 6 cases which we are going to study in this chapter. Okay, 6 cases रहेंगे. So first 3 case is on stationary plate. Okay, what happens, what is the force being exerted when water is going and hitting one stationary plate? Okay, the stationary plate can be held normal. For example, let us say this is the water which is coming. So if the plate is something like this, normal, and the water is coming and hitting it, how much force is exerted on this plate? That is the first case. Second case, water is coming and the plate is inclined. Okay, so in this case, how much force is being exerted on my this stationary vane, as well as when plate is curved? In turbines you might have seen, right? So vanes kaise the? It was curved, the vanes were curved. So third case is the most frequently used case. Okay, so when I have a curved one, what is the force being exerted when my water is coming and hitting my vane? Okay, so these are the 3 cases, and this is for stationary plate. I will be very honest with you, this is absolutely useless for us. We won't be studying this, because when the water, let us see this example, if you have a runner and you have vanes attached to this, something like this. Okay, so water is coming and hitting it, right? So what it does, it moves. It is not a stationary vane, it is a vane which is actually moving. So here comes the second part. force exerted on a moving plate. This is the conditions which we actually use when we are studying turbines. I hope it is very clear, right? Then why we are studying this? Why we are studying this? Obviously to understand this condition, the second condition in a better way. अगर मैं आपको सीधा advanced पढ़ा दिया, if I teach you advanced topic directly, can you understand? No, right? First you have to understand the basics and then you understand your advanced topics. So let us go like that. First let us see these three conditions and then we will see these three conditions which are actually important. Okay, let us continue. So the first condition is jet striking a stationary flat plate. Okay. So obviously when I am talking about stationary flat plate, let me make it very clear. The water jet is coming and striking it normal to it. Now use your common sense. Okay, many students get confused in this simple logic. What they say is, sir, पानी आएगा and plate को hit करेगा. So when the water is coming and hitting the plate, obviously what it will do, it will fall down, right? It will not go up against the gravity. That's common sense. So sir, in this diagram you are saying velocity, it is coming with some v and it is going out up in v and bottom in v, right? Half of it is going up in v, half of it is going in down in v. Sir, how is this practical, sir? What is happening? See, let me make it very clear. This is not the actual image. This is the top view. So actually the plate is not like this. The plate is not like this. The plate is something like this and water jet is coming like this. So try to imagine water jet is coming, okay, and it is hitting my plate normally. So what happens? Half of the water will go in this direction, half of the water will go in this direction. Common sense की बात है. I hope you got it. So if water is coming, let us say this is of mass m, it is coming and hitting. So m by 2 will go in this direction and m by 2 will go in this direction. Common sense की बात है. समझ नहीं आ गया? Common sense की बात है. I hope you got it. So that is how this diagram should be seen. So blindly you should not say, sir, all the water will fall down, nothing will go up. No, yeah, this is just a diagram representation. This is how it will be. In real case, I have explained you how it should look, right? Clarity aa gaya? So let us find out what is the force acting. Okay, in this chapter, two forces we will generally find out. What is the force in horizontal direction and what is the force acting on a plate in a vertical direction. In this case, we have water coming and striking normally to this stationary plate. So it is not changing its path, right? तो यहाँ पे क्या हो रहा है? There will be Vx, but what will be the Vy? Vy तो zero है. There is no vertical component of it, right? So we have only horizontal component Vx. So obviously I am interested in finding Fx. Okay, I am interested in finding what is the force along my horizontal axis. So I know my formula. So that is nothing but rho Av into V minus U. So let me make it very clear. Whenever I am writing rho Av V minus U, this is your initial velocity. Let me make it very clear. Many people confuse V minus U. Generally we use the terms U as initial velocity, V as final velocity in our physics, right? That's why many people confuse here. So let us be very clear. Please write down. Please write down. I might be denoting it like that, but in virginality, this V whatever is there, it is initial velocity and this U I am writing is my final velocity. Let us be very clear. Okay, final velocity. Because my horizontal force whatever it is nothing but change in momentum, right? So initial momentum minus final momentum. So rho Av into V minus rho Av into final momentum U, because this is m, right? So initial momentum will be m into V and final momentum in this case will be m into u. Okay, I hope it is very clear for you. No confusion, right? तो हम यही concept use करेंगे. So what is happening? The water is coming, okay, in horizontal direction and hitting the plane. Once it is hit the plane, is it going like this or it is going reflected back? No, right? It is going in other directions. It is going in vertical directions now. It is not going in horizontal direction anymore. So it is coming and hitting my plate and becoming stationary. Agreed or not? So what is the final velocity in horizontal direction? So that is 0. Agreed or not? यहाँ पे final velocity क्या है? 0 है. So what will be my Fx? That is nothing but rho Av, water which is actually striking the plate into initial velocity Vx minus 0, or you can write it as directly as V, not a problem. So what will be your force actually acting on this plate when jet is striking? That is nothing but rho Av square. I hope it is very clear, right? And what is A here? Area of my water jet. So if area jet is coming out of your nozzle, and this nozzle has a diameter d, then what will be your area in this case? That will be pi by 4 into this d square. Okay. So rho AV into V minus you use your formula where V is initial velocity and U is your final velocity. Okay. You can represent it the way you want, not at all a problem. You can write it as if VU is confusing to you, you can directly write it as V initial minus V final. This is better for you, right? No confusion, zero confusion. Like this also you can remember the formula, it is up to you. Now, even though it is not given in this text, can you tell me what is the force in y direction? The force in y direction will be 0. Why it is 0? Because let me make it very clear, there is no vertical component, there is only horizontal component, there is no initial vertical component, agreed or not? But there is final vertical component. There is final vertical component, I agree. Even then why I am saying it as 0? Apply kar lo, you know what is force. It is nothing but your change in momentum. So I can write it as, let us say the mass, initial mass which is going and hitting, that is m, into it has a velocity of Vy in y direction I want. So I know Vy is nothing but 0, right? So 0 minus I have velocity component here and here in y direction. So half of it is going up, half of it is going down in this diagram very clearly. So m by 2 into some you write Vyf, doesn't matter, and then again minus m by 2 into Vyf. So this one again cancel. So what you will be getting? You will be getting answer as 0. Okay? So there is no vertical component. I hope it is very clear for you. So Fx will only come when you are having a water jet going and hitting my plate normally. यहाँ पे vertical component नहीं आएगा, because whatever the mass is coming in this direction will cancel the mass coming out in this direction. There is no net force acting in vertical direction. Concept is clear for you, right? कोई problem नहीं है ना इसमें. Okay. So let us continue. And one more thing, what is the work done on this plate? What is the work done on this plate? You know what is the force coming? What is the work done? Use your common sense. What is work done? That is nothing but force into distance, right? Force into displacement. Is this plate moving in this case? Is it moving? No, it is a stationary plate. That's what I am saying, right? It is a stationary flat plate. If something is not moving, even though force is acting on this plate, if it is not moving, then work done on that plate will be 0. Okay. Got it? No doubts, right? So can I continue the second topic? So let us go to the second topic, when the jet is striking an inclined stationary plate. Okay, when a jet is striking an inclined stationary plate. Even before starting this, can you tell me, in the previous case I told, when the water is hitting normally to the plate, if this is of mass m, in this direction m by 2 will go, in this direction m by 2 will go, right? Now what is happening? Now let us try to understand what is happening. The water jet is coming and I have an inclined plate. So you tell me, m1, m2, just I am representing the mass, okay, mass which is going like this. Obviously I know the mass whatever is incoming should be equals to mass outgoing, right? So m is equals to m1 plus m2, I know that. Use your common sense, just tell me which one will be more, m2 will be more or m1 will be more. Use your imagination, okay? No physics required, no hydraulic concepts required, use your imagination. Water aa raha hai and the plate is something like this. Obviously it will hit and most of the component will go in this direction only, right? पीछे थोड़ी जाएगा. Obviously some water will go in this direction, but most of the water will be going along the direction of flow, agreed or not? So what is happening? This m2 will be clearly greater than m1. You can just imagine, you need not even derive, agreed or not? So similarly, you tell me, if a plate is inclined, water jet is going like this and plate is inclined like this. Now you tell me, which one will be more? M1 will be more or M2 will be more in this case? M2 will be more. Obviously, along the direction of the flow, most of the water will go in this flow, in this only when it got hit, right? Most of the water will go in this direction and some water will go in the upward direction. Clear? Common sense की बात है. You can just use your imagination and think, right? Because we all have played with water. Every day we use water for all your activities. That's why whenever I am saying these things, you can actually correlate. You need not even use derivations to solve. You can easily ask your brain and your brain will tell you the answer. This direction में पानी ज़्यादा जाएगा, this direction में पानी कम जाएगा. Very simple thing. Now let us try to analyze this. See, here obviously you will be getting two components. Fx भी आएगा, Fy भी आएगा, because it is hitting inclinedly. It is hitting inclinedly. So what you have to do? You have to resolve. It as per your plate. That's why you will be getting components. You will be getting Fx. You will be getting Fy. So to avoid all this nonsense, in the previous case, my water jet, in the first case, my water jet was acting normal to the plate and it was very easy to derive. So I will imagine even now some water is acting normal to this plate, and first I will be finding out what is my normal force acting to it. Okay, what is the force which is actually hitting my plate perpendicularly, that I will find out in the first case. Okay, how to find it out? Very simple. Your Fn will be rho Av, water which is actually going and striking, the mass of water which is going and striking my plate. So that is rho Av into your initial velocity minus final velocity. See, anytime if some water jet is going perpendicular to it, obviously इसका final velocity क्या हो जाएगा? It cannot go like this, or it doesn't get repelled because water is coming in this direction only, right? So what is happening? The final velocity will be 0 in this case. Okay, my Vf will always be 0 when the water is striking normal to my stationary plate. In this case also it will be 0. So my initial velocity, some V dash minus 0 will be my Fn. Okay, now you tell me what will be my V dash. Use your common sense. यहाँ पे दिया है this is theta. This is theta. So here only we will draw. So this is theta. Can you tell me what is this angle then? What is this angle? Angle between your Fx and Fn. What is it? So that will be 90 minus theta, because you know that is the force acting normal to the plate. Normal means 90 degrees. This should be 90 degrees, right? This should be 90 degrees. If this is theta, obviously the rest of the angle will be 90 minus theta, right? I hope it is very clear, right? So I have a V and I know this angle is 90 minus theta. Can you tell me what is this velocity component? Common sense की बात है, you know that very well. You can write the components very easily, right? If this is V, this velocity component will be V cos 90 minus theta, whatever the angle is there in between two lines. You know that very well, right? If this is V and this is theta, what will be this velocity component you want? So that will be V1 cos theta, right? Same thing I am writing. The angle in between these two are 90 minus theta. So obviously my velocity component along this Fn will be V cos 90 minus theta, which is nothing but V sin theta, because cos 90 minus theta is sin theta. So my Fn, the normal force which is acting on the stationary plate, will be rho Av into V sin theta minus 0. So I can write it as rho A V square sin theta. What is happening to my normal force? It is becoming rho A V square sin theta. Concept is very clear for you, no problem so far, right? So what will be your Fx and Fy? What will be your Fx and Fy? Common sense की बात है, I want Fx and I want Fy. Okay, so I know this is V sin theta. Okay, and what is the force which is acting? That is rho A V square sin theta. I just want force component in horizontal and I want force component in vertical direction. So this is 90 minus theta. So I can write it as this Fx is equals to your Fn into cos 90 minus theta. Agreed or not? So it will be nothing but rho A V square sin theta into cos 90 minus theta, which is again sin theta. So I can write it as rho A V square sin square theta. I hope it is very clear, right? So what is your horizontal force coming in this case? That will be rho A V square sin square theta. Similarly, what will be your Fy value? What will be your Fy value? See, what will be your Fy value? You know, this angle, this is your Fn, this is your Fy, this is your Fx. This angle was 90 minus theta. So what will be this angle? You know, Fx and Fy will be 90 degrees. So this angle is 90 minus theta. So obviously this angle will be theta, right? Because 90 minus theta plus theta should become 90 degrees. Agreed or not? So I know that this angle is theta. Can you tell me what will be Fy value? Fy value will be nothing but Fn cos theta. So Fn is rho A V square sin theta into cos theta. So this will be my Fy value. I hope it is very clear, right? See, you need not derive you need not by heart these equations. Even if you know the concept, if you can understand the concept, if you practice 2-3 times, even if it comes in examination, you can actually derive on time. Okay, so it will not take any time. Very simple topics. Okay? You just practice it twice and it will be very simple for you. Now let us continue with the next terminology, which is the same thing which I have explained you above, but we will be deriving it this time. I have told you, if the plate is if water jet is hitting the plate inclinedly, let us say this is of mass m, and obviously it will be splitting disproportionately m2 and m1. So you just said that m2 will be more because it is along the flow, right, and it is reverse the flow. This m1 will be little bit less, m2 will be little bit more. You can just say by imagining things, right? You can imagine the flow and you can say that. But now physically we are going to derive it. See, physically we are going to derive what is the discharge which is coming in this direction and what is the discharge which is coming in this direction. Let us say this is q2 and let us say this is q1. Okay, so what is the discharge? It is coming in one direction, another direction. We have to find it out. How to find it out? We will use the same equation, the impulse momentum equation, along this tangential to the plate. Okay, you know what is normal and what is tangential, right? So you know what is a normal and what is tangential, right? So if let us say we have a 90 degrees making angle, okay, so this is my normal axis, okay, and if I am drawing something, a line along this normal axis, that is normal to my plane. So similarly 0 degrees, you can say that is your tangential axis, So now I want what is the discharge it passing through my tangential axis. Okay, I know when there is some discharge going and hitting my inclined plane, some discharge is going like this and some discharge is going like this. So I want to find what is the actual amount of this q value. Okay, I want to find q1 and I want to find q2. काफी simple hai. See, you need not use rho a v square sin theta, rho a v square cos theta anymore, because I want in terms of discharge. I am interested in finding q1 and q2 values. So what I am going to do is directly I will be using impulse momentum equation along the tangential axis in terms of q only. Okay, so first of all there is some discharge, right? It is going and hitting my tangential plane, it is hitting my stationary plane, and liquid is going something like this. Some liquid is going like this, some liquid is going like this. So how much discharge is actually passing along this surface? Along this surface, you can just say, if this is theta, q cos theta. Agreed or not? That is your initial discharge which is actually hitting the plate along the tangential axis. That is very clear for you. So हम impulse momentum equation ऐसे लिख लेंगे. What is your initial momentum? So that is nothing but rho qv. We have studied in the very first, like in the very first slide we have studied, right? So rho qv is my actual force. So that's one only I will be writing. Okay, my initial momentum, that is rho q into v. No issues like here, right? But I want along this tangential axis. Just now I have told along the tangential axis, that will be into cos theta, right? So rho q cos theta into v. This is your initial momentum. And what is your final momentum? See, along this side, okay, that is rho q1. Again here the velocity will be the same, right? Velocity in which it is going, it will be the same. So rho q1 v minus rho q2 v, because if this is my surface, this I am considering it as positive and this side I am considering it as negative. That's why I am getting rho q1 v minus rho q2 v. So what is the change in momentum? That will be nothing but rho q cos theta v minus of final momentum, which is rho q1 v minus rho q2 v. Simple. So rho is common, v is common, so I am going to delete, I am going to remove it. Okay, so what I am going to get, q cos theta minus q1 plus q2 is equals to 0. Okay, I can rearrange it like this, q1 minus q2 minus q cos theta is equals to 0. This is my equation number 1. Okay, similarly I know one thing, this discharge whatever was coming, it got split into q1 and q2, right? That's why I can write one more equation, q is equals to q1 plus q2. तो ये दो इक्वेशन हम इक्वेट कर लेंगे. So when you are rearranging these terms, you can clearly write in a simple way that your q1 will come as q by 2 1 plus cos theta, and your Q2 will come just minus sign, just change it. It will come Q by 2 1 minus cos theta. Just practice one, just do it. You will hardly take 2-3 minutes, and you will take 1 minute, that's it, and you will be getting these equations. Okay, so what is the ratio Q1 by Q2, in which ratio this is actually splitting Q1 and Q2. How this is actually splitting, you can find it out. So Q by 2 will be cancelled, so 1 plus cos theta by 1 minus cos theta. This is the ratio in which actually your discharge is being split when it is going and hitting one inclined surface. I hope it is very clear for you, and use your common sense. Use your common sense. This value will be more than 1 or less than 1. This value will be more than 1 or less than 1. Use your common sense. It should be more than 1, because that means what does this mean? Q1 by Q2 greater than 1 का मतलब क्या है? That means your Q1 value is actually greater than Q2. Common sense की बात है. That's what I have said, right? If a jet is coming like this, okay, and it is hitting the inclined surface, more discharge will go in this Q1 and less discharge will go in this side. That's what we were saying, right? Now we have proved it practically. So what we are getting, even by solving all this, we can say that the discharge in this direction will be more, along the flow will be more compared to what it is coming in this direction. Okay, I hope it is very clear for you. You can just check, right? 1 plus cos theta by 1 minus cos theta. Obviously it will be greater than 1. यहाँ पे plus आ रहा है, यहाँ पे minus आ रहा है. Okay, if you are taking 60 degrees, what it will be? 1 plus cos 60, 1 by 2, 1 minus cos 60, that is 1 minus 1 by 2. Okay, so how much you are getting? 3 by 2 by 1 by 2, right? So you are getting 3, which is obviously greater than 1. So Q1 by Q2 क्या रहेगा? It will be greater than 1. So you can just blindly say that the discharge will be more when it is along the direction of flow. Okay, if something is like this, the discharge will be more here, the discharge will be less here, this will be more. But if you have something like this, okay, then tell me which one will be more, Q1 will be more or Q2 will be more? Obviously my Q2 will be more, Q2 will be greater than Q1. Okay, clear? Because obviously the flow will be like this mostly. That's why my Q2 will be greater than Q1 in this case. Concept is very clear, right? Now tell me, what is the work done in this case? Again, it will be 0, because it is a stationary plate, it is not moving. I know what is the force which is actually acting. I know what is the normal force. I know what is the force in horizontal direction and vertical direction. But the plate is stationary. Force into distance, force into anything into 0 will be 0. That's why my work done in this case is also 0. Okay, I hope you learn this concept. I am giving you one small homework. Okay, what is this homework? Let us try to understand. Let us say there is one rod of length L. Okay, so what you are doing, there is a rod which is connected to the hinge. This is a hinge. So whenever you have a hinge, what you can do, if some force is acting on this, it will definitely change its location like this, right? It will rotate something like this. Now you have to find out, you are hitting it with a water jet. Okay, you are hitting it with a water jet with some velocity v. So obviously now what it will do, it will change its position, it will try to rotate, right? So now you have to find out what is this angle theta. Just try it, just try to solve what should be the angle theta. Socho, just imagine, just apply your brain and try to analyze this problem. Even if you don't get it, not a big problem, because tomorrow in the next module, whatever it is coming, this will be the first thing which I will be solving, and then I will be going into the next cases, and probably in the next module I will complete all the 6 cases. Okay, so 2 cases are done, 4 cases are left. In the next module all 4 cases will be solved. Have a nice day. See you in next module.